Hello, welcome friends. Me Anila. The topic of my discussion is about Lee Chatelier principle. But before this, don't forget to like and subscribe my channel and press bell icon. Friends, in this video, I will tell you about Lee Chatelier principle. First of all, there are two types of reactions. One is irreversible. That means the starting material, that is reactant, are forming product and only forward reaction occurred. These are irreversible reaction. On the other hand, reversible reaction are those in which reactant are forming product and backward reaction occur and product is forming reactant. So forward reaction and backward reaction occur. This is called reversible reaction. So Lee-Chatelier principle states about reversible reaction in which equilibrium between reactant and product is established. This principle states that if a system at equilibrium is disturbed by a change in concentration, pressure or temperature, the equilibrium shifts in such a direction so as to oppose the change and re-establish equilibrium. So if we have a system consisting of reactants and products, and these are reversible reaction, that is forward reaction is occurring and backward reaction is occurring, system is at equilibrium. If we change concentration, pressure or temperature of that system, the equilibrium shifts in such a direction so as to oppose the change and re-establish equilibrium. For example, if we change the concentration of reactant or product, then what will be the effect on concentration of reactant or product? If we change pressure or temperature of the reaction, what will happen? I will tell you now. Now, factors affecting equilibrium reaction. Number one is concentration. If we increase concentration of reactants, so equilibrium shifts forwards or more product is formed. Reactant means the starting material that are reacting to form product. If we increase concentration of reactant, when increase the quantity of reactant in a reaction, so forward reaction occur and more product is formed. If we increase concentration of product, equilibrium shifts backward and more reactant is formed. So, if we increase concentration of product, backward reaction occur and more reactant is formed. For example, we have the reaction Haber process. Nitrogen gas plus 3 moles of hydrogen gas produces 2 moles of ammonia. This is the reaction. If we increase concentration of reactant, product is increased. If we increase concentration of product, reactant is formed. Backward reaction occur. So these are the changes that occur due to increase in concentration of reactant or product or decrease in concentration of reactant or product. Now the other factor affecting equilibrium position is pressure. If we increase pressure, then equilibrium shift to the side with fewer moles of gas. If we decrease pressure, then equilibrium shift to the side with more moles of gas. No effect if gaseous moles are equal on both sides. Now we take again the example of this Haber's process. 1 mole nitrogen gas react with 3 mole hydrogen to produce 2 moles of ammonia. This is a reversible reaction. If we increase pressure in this reaction, equilibrium shift to the side with fewer moles of gas because pressure and volume has inverse relationship. So increase pressure, so decrease volume, so the forward reaction occurs. because on reactant side there are 4 moles, on product side there are 2 moles. So reaction shifts forward and fewer moles of gas are produced. If we decrease pressure, then equilibrium shift to the side with more mole of gas. In this case, if we decrease pressure, then equilibrium shift to the side with more moles of gas, that is backward reaction occurs. More nitrogen and hydrogen is produced. But if we take the example of such a reaction in which reactant and product have same moles, then no effect of pressure occur. Now, temperature. What is the effect of temperature on equilibrium position? There are two types of reaction, exothermic reaction, endothermic reaction. Exothermic reaction occurs by a release of heat. Endothermic reaction occurs by absorption of heat. Now, in exothermic reaction, for example, nitrogen plus 3 hydrogen produces 2 moles of ammonia plus heat. This is exothermic reaction. That means reactant have large amount of heat and product have low amount of heat. So if we increase this temperature of this exothermic reaction, backward reaction occurs. If we decrease temperature of this reaction, forward reaction occurs. Now, for endothermic reaction, we have an example of photosynthesis. 6 mole of carbon dioxide reacts with 6 moles of water in the presence of sunlight, produces glucose plus 6 moles of oxygen. This is endothermic reaction because it occurs by absorption of light. In exothermic reaction, reactants are more energetic. In endothermic reaction, products are more energetic. So increase in temperature of endothermic reaction, forward reaction occurs. Decrease in temperature of endothermic reaction, backward reaction occurs. So these are the effect of temperature on exothermic and endothermic reactions. Catalyst. What is catalyst? It is a substance. It reacts with reactants or substrate, forms a complex, and when the product is formed, then it is released, and catalyst in the same state is recovered at the end of reaction. Catalyst does not change equilibrium position, it only speeds up the reaction. The reaction occurs with how much speed? The catalyst speeds up the reaction. The forward and backward reaction occurs quickly. So these are the factors that affect equilibrium. This is Chatelier principle. Friends, if you have any question, you can ask me on comments. I can help you. Thanks.